My name is Rouault, and I'm an independent free open source software developer, mostly focused on the GDAL, map server, QGIS, and projects. And so this afternoon I talk to you about SOZip, which is an extension of the zip format that has been designed to store, but above all, use large geospatial compressed file directly from a zip archive. So why do we need that? Why do we need an extension of zip? Well, because a number of popular geospatial formats don't come with native compression. So you have, for example, GeoPackage, which is based on SQLite 3. You have FlatGeoBuf, and you have the good old shapefile. None of them have compression. And despite the growing storage capabilities, having compression is still much desirable because it lowers your storage costs, and it also enables faster download times. So it's really interesting to think if we can provide some form of compression for those formats. So what are our options? So one could be to add compression within each format. So for example, for SQLite, you have an extension which is called CROD. And it works by compressing each SQLite page independently. But this is a proprietary extension, so obviously in this audience we are not really fan of that. And beyond that, one drawback is that being a non-standard extension, if you want to distribute data, it's not going to work very well if your consumers have to use something that is not standard. So the other approach would be to not modify the file format themselves, but put them inside a compressed archive format like zip, tar, or 7-zip, and try to make the best of it. So we decided to work with zip because zip is really widespread. I mean, every operating system supports zip. It's just a one-click operation. It's really easy to deal with. It's very portable. It compresses decently. I mean, it's not the best compression codec you can imagine, but it's still very much okay. And so, for example, here I've put an example with my currently favorite test dataset, which is polygonal footprints of buildings in New Zealand. So with uncompressed GeoPackage, it's 6 gigabyte file, and one zip, it's 480, so you have a compression ratio of 3.5 roughly. And generally, you can achieve to 2 to 3 or to 4 in the best case compression ratio with zip. But the main drawback is that usually when you put data in a zip, it's like it's locked in it. You have to uncompress it before being able to use it. So that's really the point that SOZip tries to improve. One of the interesting things of zip is that it has an indexing mechanism. So towards the end of the file, you have a directory which contains the start of each compressed file. So you can already find very quickly the beginning of a file. So it's possible for a smart enough reader to start just reading a file within a zip. But the main issue is once you have located the file, you have to read everything from the start of that file towards the end of the file, or at least up to the point you're interested in. And if we're talking about gigabyte large files, could mean several tenths of seconds to reach the point you're interested in. So that's really the issue to solve. And typically, the VSI zip virtual file system in GDAL can do that part of sequential reading to access the part of the file you are interested in. So before going to what SOZip brings really new, I should recall a few things about how zip compression works. So the historical codec is Deflate, and it's made of two main parts. So you have a dictionary-based compression, which is LZ-77, and you have the Huffman compression that is applied afterwards. So LZ-77 it uses what they call a sliding window of 32 kilobytes, which goes over uncompressed data as it is compressed or decompressed, and it tries to identify repetitions, and each time it finds a repetition, instead of putting the compressed data, it would just put a tuple with the length of the repetition and the offset where it was found. And after this LZ-77 compression stage, you have Huffman compression, which basically tries to minimize the amount of bits you need to encode the different, either the literal characters or the bytes and length distances. Another thing about the Deflate compression is that it works with blocks. So compressors are free to use blocks as they wish. So you could potentially put 10 gigabyte large compressed file as a single block, but you can also split into multiple blocks. And you have two different kinds of blocks. You have of course, LZ-77 compressed blocks, which can be of unlimited size, and you have potentially uncompressed blocks, which can have a length to 65 kilobytes. So another thing is that a block can potentially reference symbols that are found in a previous blocks. And as the aim of SOZip is to provide random access, this is a feature we don't actually want. We want each block to be independent from other ones. So what do we need to do to provide random access? There are two potential solutions. One solution is to serialize the state of the compressor at regular intervals, so you can have kind of save points. That works. Actually, there are implementations doing that. But the issue is that each time you have a save point, you have to save the sliding window, which is 32 kilobytes. So you don't want to do that too often because it would increase the file size in a quite dramatic way. Or the alternative is to use to ask the compressor at regular intervals to flush its state and more exactly to not reference symbols that were in a previous block. So on this drawing, what is allowed is the green arrows, where within a block you can reference a symbol that was found before, but you don't want block 2 to reference symbols in block 1. So what can we use to avoid a block from referencing a symbol in a previous block? We can use what is called a full flush mode in the good old zlib library. And this does many things. So it resets the encoding dictionary, it also makes sure that the compression stream starts at byte boundaries, because potentially blocks could start in the middle of a byte, so that's not convenient. It also, this full flush mode, it also emits 0-byte uncompressed block, which can be used as a signature to see that you have a block that is independent from previous blocks. And actually, it's not a new technique. It was used for years by the PIXI utility, which is probably not well known, but it's really worth looking at it if you don't know it. So it's a parallelized version of the GZip utility that can produce such independent blocks, and it also multi-threaded, so it can compress a file very, very fast. And the good thing about that is that all existing zip readers are compatible with that. I mean, it just uses standard mechanism of deflate, and readers don't even realize that the full flush occurs. So we have now pretty much all the ingredients we need to build SOZip. So inside a zip archive, we say that a file is SOZip optimized if actually there are two files. The file with the payload you're interested in, which is the first one, where you have the deflate stream that is split in several chunks. A chunk corresponds to the same amount of uncompressed data. Typically, a good value I found is 32 kilobytes. And the other ingredient to make SOZip work is to have another file, which is an index file, where you have a mapping between the offsets in the uncompressed stream to the offset where the compressed chunk starts. And with that, you're able to decompress the random part of the file very quickly, because you just need to read the offset of the, where the chunk starts and decompress just at that point. So globally, if we look at the structure of the SOZip archive, so it really reuses all the parts of the zip archive. So towards the end, you have what they call the central directory, which is the list of all files in your zip archive, and with a pointer where the file starts. And so in this example, the file, the my GeoPackage file, and the new addition of SOZip is to just after this compressed file to write another file which uses zip, the zip way of describing a file, but which contains the index. And the thing is that you don't declare this index file in the central directory, so it's invisible to readers that don't know about SOZip. So if you open a SOZip archive, it will really look like a regular zip, except for SOZip-aware readers that will know that they might have to look just after the file of interest if there is an index. And if there's one, well, they can use it. So what are the pros and cons of SOZip? On the pro side, well, its really main point is to make zip a workable format to allow random access to really large files from the zip file directory. It allows to have multi-threaded compression and decompression because each chunk is independent from the previous ones. And the consequence of that is that each chunk can be potentially decompressed using other implementations at that level. So for example, you have Deflate, which roughly gives you 2 times performance improvement over that level. So all that combined together can bring performance improvement. And another good thing is excellent backward compatibility, because at worst, ZipReader will not be able to use new capabilities. And on the test I did, I couldn't find an existing ZipReader that would reject a SOZip file. Well, maybe there are some, but I mean, it really it has really good backward compatibility. Of course, it inherits from the same limitation of the zip format, so you cannot easily update an existing file. If you want to do that, you have to put a new version at the end of the zip or rewrite the zip. And another consequence of the regular flushing of the dictionary is that it degrades the compression rate. The value will depend on your actual data, but it's roughly just a few %, which is much better than having no compression at all. So what about the implementation? So there's a GDAL one in the last GDAL version, which has several components. One is improvement of the existing VSI zip virtual file system. So it will generate by default SOZip-enabled archive for files that are sufficiently large, so it has some benefit. It will use multi-threading capabilities to compress files, and it of course detects the hidden SOZip index, and it can use it to provide very fast random reading. And there are a couple of other methods, so you can compress easily a file as a SOZip, or ask if a file within an archive has a SOZip index. The GeoPackage and shapefile drivers have been improved to directly generate SOZip. So if you do OGR to OGR, my.geopackage.zip and my GeoPackage, it will convert your GeoPackage as a SOZip-enabled file. And you have this new SOZip command line utility that is available as well as existing GDAL utilities, and with that you can list the content of a zip file and check if files within it are SOZip optimized or not. You can validate a SOZip file, and you can create a SOZip file from existing files and compress them, and you can also compress an existing zip archive and optimize it as a SOZip. There's also a Python implementation, which is actually a fork of the core zip file Python module. So you can install it with pip install SOZip file. So as a fork, it has an API which is fully compatible with the existing module, and with just a few new keywords, you can create a SOZip-enabled archive instead of a regular zip. And you can check if a file is SOZip-enabled. And you have what I would call the indirect implementation, because there are software which use GDAL, so map server with just a tiny enhancement will generate SOZip archives if you define some format to use zip compression. And for QGIS, if you use QGIS against GDAL 3.7, you automatically benefit from the optimization, and typically you can just drag and drop a gigabyte large compressed GeoPackage file in QGIS, and it will open instantly, and you can zoom in, zoom out, and just work as if the file was uncompressed. A few timings. So for the zip generation here, I show that you can get a 6-time improvement to generate a SOZip file. And if you use bulk reading using the quite new Rouault array interface, here to show the cases where you will really feel the cost of the decompression. But I mean, it's already on access which are really, really efficient and use very little CPU. And here are other use cases where you just want to read a part of the file. So, for example, on this file, which has 3.2 million polygons, you just extract a few tens thousands of them, and you can see that the time just increased by 10% if you do this spatial filtering over the SOZip file compared to the uncompressed file. So it's really good. And if you just extract one single feature, the timing difference is just hardly noticeable. It's like 1 millisecond in addition to 44. And I guess you might have a question in mind, is SOZip cloud optimized? Well, there is not a clear yes or no answer to that. SOZip by itself doesn't transform a file format into a cloud-friendly one if it was not already cloud-friendly. So I would say it will preserve the cloud-friendliness of a file format, but it will not make it automatically cloud optimized. So here on this drawing, if you need to access from some operation, you need to access 4 parts in the file. Once it will be SOZip compressed, you will still have to locate those 4 parts. But if a file format is already cloud optimized, if you combine the VSI curl, the network access capabilities of GDAL with enhanced VSI zip virtual file system, then you get cloud friendliness. So what remains to be done? Well, I would say mostly use it. It's available now. GDAL 7 has been released 1 month and a half ago, so you can already use it. And I would encourage data producers and distributors to try it, because at worst, existing readers will not be affected. And zip-aware readers will be able to get the benefit of SOZip. And really, it's the same idea as cloud-optimized GOT for the COPC format. It's really to add extension, but in a way that doesn't prevent existing readers from being able to use it. And another thing that could be done, not by me, because JavaScript is definitely not the language I'm familiar with, but I guess it would be interesting to have some libraries that use SOZip extension, for example, to improve the performance of FlatGeoBuf over HTTP. Yeah. And that's it. Thank you.
Any questions from the room? Yeah. So the examples you gave were with the GeoPackage instead of zip file?
Yeah.
And there was like one index file for the GeoPackage file?
Yeah.
For shape files, do you need one index file per file in the whole shape file sidebar thing? One for the HTTP, one for the SHX, etc., etc. Okay. And the other question is, yeah.
It depends if you have just the .prg file, which is a small file. I mean, there is no SOZip file, SOZip index, because it's just too small. So, by default, the GDAL implementation starts to create a SOZip index if your file, uncompressed file, is larger than 1 megabyte. Well, it's just a default. You could increase or decrease the CFF value.
Regarding the end of the tank, is it possible or is it implemented to have the tanks in a size so that a feature does not fall in between two tanks?
Well, it's not implemented actually because you have seen there is nothing geospatial actually in SOZip. It doesn't know anything about your payload. But if you know that your payload is has such predictable boundaries, you could adapt the chunk size to fit nicely with the structure of your payload.
It's possible, it's not done.
Well, I mean, it's done, but it's a responsibility of the user to really tune the default value to what makes sense to optimize for the use case.
So, when are we doing cloud optimized files? It's a crazy idea. I love the crazy ideas. When are we doing that?
Why do we need to do that?
Because we can.
Yeah,
We're crazy geospatial developers.
Yeah, but shapefiles. I mean the PDF format. I mean it's quite large if you have text, particularly if you have text records, and you must create the field to fit with the largest string you need to put, and so yeah. You would better with FlatGeoBuf.
It's not so boring.
Well, I really miss having compression of GeoPackages in general, and I'm looking forward to try this out. If I have a driver in Python, let's say a GeoPackage driver, can it automatically add the SOZip to that? If I create a dataset using a QGIS driver in Python, can I give it some create options, or could I call the file.zip afterwards to automatically have it wrap this QGIS in?
Yeah, so it's something specific I added to the GeoPackage driver, because GeoPackage is widely used. It can be done in other drivers if it's needed.
But how do I tell it to make a SOZip instead of a SOZip with a GeoPackage inside?
Well, you don't have to tell GDAL to create a SOZip optimized file, because I mean it's a default behavior in GDAL 7. But you can with some configuration option disable it, but there is really no point given that the backward compatibility is really good. So, yeah.
Any other questions? Yes, one. For files served on this format, would it make sense to disconnect the compression on the transmission for the web servers to just send directly the payload of the request without compressing again?
I'm not sure.
Yeah, on our server you can have any files, JSON files, and then you can request them, and the web server can just compress the payload and send it to the client, and the client understands that it's a compressed file and they compress it. But if the files are already compressed, it would make sense then to disconnect that behavior on that kind of services, right?
Well, the thing is that if for several streams data, that's not really the use case of SOZip. SOZip is more for accessing static files rather than dynamic content. Well, you can say that.
Any other? No? Then, thank you. Thank you very much.